Hello everyone, this is the Transistor Tech, and today I'm here on a new video about another project of mine. I will try to make this short video. I don't want to bore you so much, like in other videos I did. Like the Gravity Sim Simulator video, I will not edit this video. I really don't care too much. Just a notice, if you're a diehard fan of the channel, and well, I guess technically 46 people are. My site has not been online for a while now, mainly because, like, for a year, mainly because it wasn't getting much traffic. It was a hassle to keep updated, and everything else was always like really, really slow. So it was just shut down a few years ago, like last year, practically. Um, this is a bit random, but I just wanted to say it because I never actually said that my site is down, but who cares? Okay, so today project I will showcase is my Matrix Python. Is a simple project that I made on Python that tries to replicate the Matrix effect. I don't know if you know it from the film. Just to show what I mean, let's run the last version, that is the V4. As you can see, this is about what I made. This is the newest version, but I will showcase to you all of them. So let's go from the first. Clearly, the first version is the most bare bone of them all. Is I will say I'm sorry for the flashing, but it's sadly something I fixed only in the V4. As you can see in the V1, we have really simple graphics, no gradient, no color, and also V1 is bugged. It's kind of a funny thing, but in V1 it will start slowing down because there is the way I stored the string that we are going to print to the command line uh, is not shortened, so it just gets bigger and bigger, and as you can see, it gets slower and slower. Okay, so let's start with code. Here you can see these two are just tests to see the new rendering system in V4. This is a simple package that adds a few functions. Clearly, everything is made in Python because I've been learning Python in the last few months thanks to my university course on Python. License, read me if you're interested. And ignore this file, just use it to run the code, nothing else. Okay, so let's start from V1. And let's try to explain everything that happens. First, from these simples functions that are used practically in all the versions. Um, this is just used to generate a number between a max and a limit with exceptions. Is used in a few cases because when we decide in which line to render the new, like, I was, yeah, it's another line, but let me just open again. So as you can see, each frame we decide a new line to render, this one that I'm following, and we need to choose one that is not in a space that is already occupied. So that's why we use this type of generation. It just generates a list of all valid values and then chooses between one of them. We have then a remove access. This function simply removes all the elements in a list that are more than the one we want. Because, for example, when I make a new line, I just add a new line to the list that represents the what we're going to print. Uh, and then we want to remove the last one because we don't want it anymore. Also because the longer the string, the more time we need to actually make all the math. So a shorter string allows us to keep the FPS stable. Indeed, in this version, the V1, I didn't do that, so the simulation slows down over time because there is a string that keeps getting bigger and is never shortened. Matrix chart, this is the one that renders, chooses which character to render. Doesn't really render it, it just chooses which character to be used as printing. As you can see, characters change, and there is a random selection of characters, and that's then which character to be chosen is decided with this function. It just generates a random number in this case and transform it from in the char is the function that transforms a number to its value to its letter or symbol using the ASCII character list and also Unicode, but we just care about ASCII, so ASCII is from I think position 0 to 256. We have these a few variables. These are the important ones if we want to modify to change how the simulation works. And here we have the main code that renders everything. And in short, we first clear the frame, and then we just make some simple math to make the new line. We save which line we are printing because we want to. So, like for example, if we started printing this line, the next frame we need to print the second cursor on the line. And the last step is just to change the letters because if you saw before, letters change over time. They're not always the same. Um, and there is a way to do it. The way I do it, if I remember correctly, I just like yeah, I just modify in because in every version I changed how it worked because depending on the implementation, I couldn't use always the same method. In some cases, I just make a new frame and change each letter. In this case, I think I'm changing directly the letter inside the frame. And to be precise, the frame is a list of strings because each it's a list containing each string. So this is a string, this is a string, and it contains each one of them as a list. At the end, we just join all the strings and print the frame, and then sleep for a while so it doesn't really go too much fast. So this is V1, that is the worst probably, but that's why it's a V1. So let's go to V2. In V2, what I did is first fix the bug where uh, the simulation was it's not a simulation, the animation was low down, and I added a gradient to the letters. Okay, this is a bit odd. Okay, that's okay. Oh yeah, I know what's the problem. So what's happening is exactly the width is too big. So when you start rendering it, like lines starts to overlap with each other, and you have a hole between them. If you zoom out until you have 200 rows, no columns, my bad, like it's written here, it starts to run it properly. So let's make a more like a smaller number. Okay, now should be better. Okay, perfect. So as you can see, V2 is way better looking. We have a gradient, and also the simulation doesn't slow down. Making a gradient was a bit of a mess because printing in the terminal is not easy, and you need different ways to print stuff. So the way I render the colors is by using, let's see where it is. Okay, this end string. End string sounds like are stuff that you add at the start of a string and then specifies how it works. It's the same as backslash n. This makes the text go to a new line. This adds color. Now the main difference in this version, the new things that are added, is that the metric char has been modified to also include a color that is a gradient based on the position of the letter in the line. So higher letters in the top of the line are darker than the one on the bottom. And then instead of returning just the character, it returns also the color. As you can see red, green, and blue because you can choose any color in the RGB spectrum. I just use the green channel. Is technically it should go from green to white, but I didn't care too much. I just wanted to make it work. Modifying the color is just the thing. It's just trivial. Doesn't really, it's not really a challenge by itself. I also had to make a copy color because, as I said, every time I modify how the rendering works, I need to change how the letter changing code works every time. So I needed to add this function that just copies the color from the old character and pastes it to the new. The problem with this is that these types of strings that start with the backslash don't really count as a string, meaning that if you try to access it normally, like the character from position 0 to position, I don't know, maybe 7 or 8, Python will not return this string. So you need to first make it um, a row string, not really a row string. I don't really remember exactly what I did here. I think it's probably turning it into a string that actually counts all these characters as characters, then copy the color I want into the new character, and then re-encode the string into something that actually prints as color. Because of also colors here, the frame has been changed to a list of strings, meaning instead of having a list of string that go for the entire line, we have a list of characters because we have the list that contains all the lines, and each line is a list that contains all characters. And this means that we need to join twice the time, twice everything together. At the end, it's always the same thing. We are just making them. In this case, I changed the way the frame with changing the letters works. We make a copy of the actual frame that just edit all the single letters into new letters, so the letters change. Now, V3 is not really that much interesting. It's just some quality of life, I would say. First of all, the size is based on the size of the terminal, meaning like if now I zoom out and make it start again, we're going to get a size that is the same as the terminal, so it's a bit nicer. Let me just check exactly what I did because I wrote it here. Yeah, I didn't write what I did. Um, Oh yeah, now you can choose how many frames per second you want. That's one of the features I added. The dimensions are based on the terminal size, and I think that's mainly it. I didn't really add much else. It was just maybe I did some refactoring, I fixed a few things that were a bit ugly in the V2. Um, let's see if I can see what I did. Okay, let's check. Create a V3, height and width, remove and use code, exactly organized. Merge, update, maybe for, yeah, I didn't really do much. It's just the FPS thing, these two things, and then probably I fixed a few things in the code to make it a bit more readable or in general easier to work with. Not really that much interesting. It was just like finishing the V2, a bit of polishing. And this is the last version using OS System CLS to clear the terminal and reprint the entire frame. As you can see, the problem with this method is that the frame blinks and it's really annoying. And the reason this is happening is because we first clear all the screen. So we have for a few frames a completely black screen, and then we print everything. This takes time. So the blinking you see is because sometimes the screen goes black. Now, okay, now you saw it really well. So to fix this, I had to use a really nice, this is useless, library called Curses. And this library is used to make terminal applications. This meant that I had to practically rewrite all the code for this new version. Also, in V4, we don't have anymore all the functions inside the script. I did a script that I imported called matrix utils that just has all the possible functions we would need. I also added a new one that is join list of strings, because if you have a list of lists of strings, it's not as easy to join everything together. And so I just made a function that does it for me. Okay. This is the main function that renders everything. I usually like to make the render system uh, outside of the main loop. As always, we have all the settings, but we have not as many because the size of the application is really based on also on the terminal. The rendering is nothing mo so much different from the other ones. Is just changed to work with the new version. And no, I think we're wrong. It's probably almost the same because at the end of the day, we just need to make a big string. The way it changes is not the rendering of the frame itself, is how we print it. So I think it's yeah, here. Mm, mm, mm. Here we're making the colors. Yeah, th this is where we no, my bad. Here is where we are adding the string, and at the end we just need to join everything together. We need to render the frame. Here we're just adding a status bar to have some information on the simulation. So let's check it out. This is probably the best one I ever made, clearly because mainly because it's V4. You know, V4 is the best. Okay, so as you can see in this new version, first of all is what if I zoom in? Okay, no, it just crashes. Yeah, only problem is that if you zoom in, the code tries to print the lines in a size that doesn't exist, so it just crashes. Um, yeah, exactly. Okay, so now that we have a bit of a zoom in, as you can see, there's no flashing anymore. That's a really nice feature of this library. And we have a status bar that is pretty. So we have the number of frames. This is useful for like debugging. Like when I was doing this version, I noticed the same bug in V1. Like I didn't know V1 had a bug. I found about it like doing V4, and this was very useful. Sorry, this was very useful to like see in real time all the variables that you need because you cannot print terminal while you're using this. So if you want to have some debug options, you need to add them here. And in this case, I also have the escape button, so Q goes away. This is honestly really nice as a like a, I would not say a wallpaper maybe, but um, wait, let me just. It's a bit annoying how this thing works. I think it doesn't, the terminal doesn't really register that you are in a different size. I don't exactly know how it works. So CD matrix Python CD versions Py. Okay, now is the correct size. So I don't know why this package doesn't really sometimes notice that the size of the terminal has changed when you relaunch the script. I think is something to do with how it finds that information. But anyway, this is clearly, as you can see, maybe the best version. You can change all the parameters you want inside the script itself. The really only parameters that you can change is the columns length, so how long each column is, the change probability, so what's the probability for a character to change on each frame, and the FPS that's just this how fast the rendering goes. Sadly, because I didn't care too much to do it right, the FPS just mm, chooses how fast the thing goes, doesn't really increase frames per se. So if you increase the frames, it will just go faster. If you decrease the frames, it will just go slower. It's probably more of a speed of the frame. Also, the way it works is kind of stupid because I just do a time leap of 1 over the FPS. Um, because you know time is 1 over frequency, FPS is the frequency. So if you increase it like to a really high number, it doesn't really care. It's not precise. It's like at low frames, it probably is correct. I'm probably doing like 23 frames a second, not really 24, because the speed of this thing is pretty high. It can run really fast. Like if I go 9999999, okay, let's save it and let's restart the simulation. As you can see, it can go really fast. It is doing 1, 2. like around 100 FPS a second. So if we say 24, it should probably be actually rendering 24 frames a second, maybe a bit less. If you go like to 100, it's probably not rendering 100 frames. No, if you're at 1,000, it's probably not rendering 1,000 frames a second. Yeah, I think that's all for today. I really hope you enjoyed this video. I'm sorry if it's a bit of a mess. I'm not really a good YouTuber, and I don't really care. It's just I do sometimes videos about my projects just as a showcase, just as something nice to have made. You can find all the code in my GitHub on Starlinator. As you can see, that's me. There's also my channel here. Now actually at university, so maybe you will find something spicy in the future. I don't know exactly. I don't think so, but that's something you can find. So go check it out if you're interested, and maybe I will do a new version. If I do a new version, V5 is going to have a gradient because that's the thing I'm missing in V4. As you can see, the letters don't have a gradient. It's just all green, and it really bothers me, and I want to grade it. But I'm not sure I will do a V5. Maybe if I have nothing to do, because the reason I started doing this is because we are doing a Python course at university, but it's stupidly easy. So like Monday, I just do the lab of the week, and I don't really care about anything else. So I don't have anything else to do. So like sometimes during lessons, instead of listening, I just do stuff that I think is actually more productive. So yeah, that's everything for me from the transistortech.com. And if you like what I do, subscribe. I guess I don't really care too much. It would be nice. I'm not lying, but no pressure. Don't worry. I don't really care. Okay, that's all. Have a nice day, guys.